In this lesson, we are going to look at some more characteristics of quadratic functions. X-intercepts. These are the point or points where the graph crosses or touches the x-axis. So in this graph up here, you can see that there are two x-intercepts. Think about this. How many possible number of x-intercepts could a quadratic function have? So think about a parabola. The parabola being a U shape that opens up or down. How many different possibilities of x-intercepts could there be? We could have no x-intercepts, one x-intercept, or two x-intercepts. So as you can see, maybe it opens down and starts below the graph, or it could open up and start above. One intercept is when the vertex is on the x-axis, whether it's opening up or down. And two is when it actually starts below the x-axis and opens up, or the other way. So 0 x-intercept, 1 x-intercept, or 2 x-intercepts. Zeros in a function are the value of the variable that makes the value of the function equal to 0. An x-intercept we just looked at, it's the point or points where the graph crosses or touches the x-axis. And the roots are the values of the variable that make an equation in standard form equal to 0. They could also be called solutions. The thing to keep in mind, roots, zeros, and x-intercepts are all the same thing. It's just a different term depending upon the situation that you are dealing with, but they all mean the same thing. For the graph, determine the roots. This question might have been, for the graph, determine the x-intercepts. Or it might have been, for the graph, determine the roots. So it could be roots, it could be zeros, or it could be x-intercepts. So what we do is we look at what are these points that the graph intersects on the x-axis. It is at 0 and 2. So there are your roots, there are your x-intercepts, there are your zeros. We want to determine the x-intercepts. Again, it could have been using different terminology. So we've crossed the x-axis at these 2 points. That is when x is at -1 and when x is at 6. A quadratic function can be written in vertex form. When we make y equal to 0, we are now solving a quadratic equation. When we find x, we have solved the quadratic equation, and the x values found are called the x-intercepts, the roots, the zeros, or the solution. So again, you may see the question written in different ways, yet the process is always going to be the same. So some of the ways you might see the question: the roots are, the zeros are, the x-intercepts are, or the solution is. The process is going to be the same for all of these. An inadmissible solution is the root of a quadratic equation that does not lead to a solution that satisfies the original problem. So when we're dealing with situational problems, sometimes the x-intercept might be a negative and a positive value. But in that situation, only the positive value makes sense. So the negative x-intercept would be called the inadmissible solution. If the quadratic function is in vertex form, another strategy is to let y equal 0, then isolate the brackets, and square root both sides. The y-intercept is the point where the graph crosses or touches the y-axis. To find the y-intercept, you let x equal 0 and solve for y. So you would use order of operations. Here we let x equal 0. Then we are going to simplify what's in the brackets. Then we do exponents, then multiplication, and then subtraction. And the y-intercept is always written as 0, and then whatever the y-intercept is. Domain. Domain is the set of all possible values for the independent variable, which is the x value, in a relation. We talked about domain back in Math 10 for linear functions. quadratic functions, it's a little bit easier. If you are not dealing with a situation, if it is just a graph, the domain is the set of real numbers. You can write it as x is an element of reals, or we can use interval notation, which is what you may have done back in Math 10. What it is saying is we are going from negative infinity to positive infinity, because the graph extends in both directions infinitely. So it will end up covering all of the negative x's to infinity and all of the positive x's to infinity. When a problem can be modeled by a quadratic function, the domain may need to be restricted to values that have meaning in the context of the problem. So in a situational question, the domain is not likely going to go from negative infinity to positive infinity. But in any other case, when it is just a graph or just an equation, this is what your domain would be. The range is the set of all possible values for the dependent variable, which is the y value, as the independent variable takes on all possible values of the domain. For a quadratic function, the range is a subset of real numbers. Because a parabola has a vertex, we do not go from positive to negative infinity, but you are going to go in one of the directions. Interval notation is probably the easiest way to write this. And what you do is you look at where your vertex is, and you find its y value. That is your highest or your lowest point. Because it is included, we use the square bracket. Now, because the parabola opens upwards, we are going in a positive infinity direction. So that is why it goes to positive infinity. And then it is a curved bracket because we don't actually reach infinity. So your domain is generally your vertex or your q value, the q value of your vertex, with the square bracket, and then positive or negative infinity with a rounded bracket. We want to find our x and y intercepts, our domain, and our range for each of these. We'll start with what should be the most basic. Domain. There's no situation, so it's just negative infinity to positive infinity. The range, what is your q value? It's -8. Are we opening up or down? Because a is positive, we are opening up, which means we are going towards positive infinity. There's your range. To find the y-intercept, we let x equal 0. So now what we do, we go y equals 2 times 0 plus 4 squared minus 8. Simplify up in your bracket, we'll have 4 squared. Do exponents, multiplication, and then subtraction. So the y-intercept is at 0.24. The x-intercept seems to cause the most problems. But if you remember the steps, it's not too bad. You're going to let y equal 0. So we are going to have y equals 2 times x plus 4 squared minus 8. Now what we want to do is we want to isolate the x, and the x happens to be in the brackets. So we need to isolate the brackets. So we're going to start by adding 8. We'll have 8 equals 2 times x plus 4 squared. We need to isolate the brackets, so we'll divide by 2. To get rid of a square, the inverse operation is square rooting. Up to this point, usually doesn't cause a lot of problems. Here is where some people forget a property. The square root of 4, when you're finding x-intercepts, is not just the positive square root. You have to take positive or negative 2 equals x plus 4. Now we are going to subtract 4. And now what we have is we have negative 4 plus or minus 2 equals x. That plus or minus is still on the 2, not on the 4. So now we have 2 possible answers because we have 2 x-intercepts. So do one with a positive 2 and one with a negative 2. So we'll have negative 2 equals x and negative 6 equals x. And there are your x-intercepts, and you can write them as ordered pairs. So let's do the same thing with another question. Domain, negative infinity to positive infinity. Range, your q value. Now it's a positive a, so we're opening up. So we are going to positive infinity. Your y-intercept is let x equal 0. So we got y equals 0 minus 3 squared plus 7, which is negative 3 squared, which is 9. And 9 plus 7 is 16. So it's at 0, 16. To find your x-intercepts, you let y equal 0. So we've got 0 equals x minus 3 squared plus 7. We subtract 7. We have negative 7 equals x minus 3 squared. There's nothing in front of the brackets to divide by, so now we square root. Now, try square rooting negative 7 on your calculator. Hopefully you remember that this is not possible. You cannot find the square root of a negative value. You will get an error. At this point, if that number is negative that you are square rooting, there is no x-intercepts. So this would be one of those parabolas that either opened up starting above the x or opened down starting below the x. So you would be done. All right, let's look at the last one. Again, domain is negative infinity to positive infinity. Range is your q value. Now our a is negative 1/2, so we are opening down, which means we are reaching towards negative infinity. Our y-intercept, we let x equal 0. So we'll have y equals negative 1/2 times 0 plus 1 squared plus 10. So we'll have 1 squared, which is 1. Multiply together, you'll get negative 1/2. And you end up with 9.5. So your y-intercept is at 0 and 9.5. Finding the x-intercept. Let y equal 0. So we will have 0 equals negative 1/2 x plus 1 squared plus 10. We want to isolate the brackets. We're going to start by adding or subtracting our q value. Now, when we have a fraction, we are going to multiply, and I'm going to multiply by negative 2 because that's going to eliminate everything that's in front of the brackets. So I'm going to have 20 equals x plus 1 squared. I'm going to square root. Now, 20 is not a perfect square. Round it to 2 decimal places unless otherwise noted. Remember, plus and minus 4.47. Subtract the 1. So we're going to have negative 1 plus or minus 4.47. Split it into 2. One with a plus, one with a minus. So we end up with 3.47 equals x and negative 5.47 equals x. We can write it as an ordered pair with the x coordinate being first, and you have your x-intercepts. For all quadratic functions, the domain is the set of real numbers and the range is a subset of real numbers. When a problem can be modeled by a quadratic function, the domain and range of the function may need to be restricted to values that have meaning in the context of the problem. The roots of a quadratic equation are the x-intercepts of the graph of the corresponding quadratic function. They are also the zeros of the corresponding quadratic function. So roots, x-intercepts, zeros all mean the same thing. For any quadratic equation, there can be 0, 1, or 2 real roots. This is because the parabola can intersect the x-axis in 0, 1, or 2 places.